the lighter toned, flatter Gillespie rock in the foreground, and in the middle of the scene, a loose, darker block, which is a piece of the Point Lake material. Firmly in place behind this loose rock, stretching almost all the way across the image, is an exposure of the dark rock of Point Lake that's seated in place, and that's about 20 inches tall. We'd like to take a closer look as we come back and do some contact science with the robotic arm and do more imaging to try to figure out what kind of rock it is and how it formed. It's not layered like the rock below it, and the Swiss cheese texture suggests that it might be volcanic lava or possibly sedimentary. The next stopping point will be Shaler. Image Crisp 2 is a broad view of Shaler, showing you the extent of this 50-foot wide exposure of spectacularly cross-bedded rock that we think was probably stream deposited. Now we want to go back and do paleohydrology, which is a fancy way of saying we want to study the geometry of the layers and structures to figure out how fast and in what directions the water was flowing and what the water depth was when the streams were forming these rocks. We'll zoom in on the right-hand upper corner of this image in the next image, Crisp 3. Here you can see the layers at different angles. That's the cross-bedding that formed as underwater dunes grew and migrated downstream. We're also going to want to collect chemical data this time so that we can compare Shaler to the other rocks that we've looked at so far. The trip to Glenelg region has been well worth it. The science team is very pleased with the great results that we've gotten. Once we are done with these three activities, the Dan Traverse, Point Lake, and Shaler, we're going to hit the road and embark on a really new phase of the mission. Jim Erickson will talk more about this in his concluding remarks.
Thank you, Joy. Now we should take a look at the Erickson 1 image. In the upper right, we see the Bradbury Landing and John Klein, where we performed our first drill campaign. In the lower left is the entry to the slopes of Mount Sharp. The red ellipse represents the approximate boundaries of our swath of possible drive paths. The science teams are now busily using the orbital imagery from MRO and Odyssey to scout for some scientifically interesting locations along the way to create a menu of possible stopping points. Simultaneously, engineers are busy deciding if there are vantage points within the swath from which to view various parts of the discarded entry, descent, and landing system that we use to set down safely on the surface. We'll be planning the general path in the next few weeks, and then we will start our trek to the base of Mount Sharp. Along the way, we will likely stop at some of the locations we eventually identify through the science and engineering evaluations. We will be on our way to Mount Sharp, but we are on a mission of exploration. If we come across scientifically interesting areas, we are going to stop and examine them before continuing the journey. With that, I'd like to turn it back to Jane for questions.
Okay, thank you very much, everybody. And for reporters out there, if you do have a question, please press *1 so that we can get you in the queue and call on you, and you'll need to give the operator your name and your media affiliation. I wanted to point out that we do have a status report, sort of a mini news release that goes along with today's event, and that is now posted on the follow along page, which hopefully most of you are on now if you're following in this way, and that's http://go.nasa.gov/curiositytelecon, and just click on related release. Okay, we're going to take our first question now from Dave Perlman at San Francisco Chronicle. Good morning, Dave.
Hi, good morning, Jane. How are you? Good to talk to you. Hey, this is a question for Joy Crisp. In Crisp 1 as the image, can you go a little further? Is it possible to go a little further in what you think those holes, you mentioned Swiss cheese, and I'm looking at it right now. What do you think they would cause them? Or are there things embedded in there, or what?
Right. So the two main ideas that we have right now with the pictures that we acquired when we visited last time, and we were further away than what we hope to get when we come back. One idea would be that this could be a lava flow, and those are gas vesicles. And you often see in volcanic rocks on the Earth, those kind of holes are sometimes filled in by secondary minerals. So you can see in that block in the foreground these round, bright things that probably are something filling the holes in that block there. So that's one possibility. And then the other could possibly just be some other kind of massive rock, like a sedimentary rock that happens to not be layered, and either the holes are etched by wind, or there was some mineral that has weathered out, or there were just gases in that rock as it was forming, and it's left holes in that rock. So texture is going to tell us a lot when we go back and look at this up close. It might be very revealing as to what kind of rock this is.
You're basically kind of another mystery on the planet, right?
Oh, yeah. It's a nice mystery. And it really shows up as a sharp contrast, this rock sitting right on top of the Gillespie unit here, that it's something different. There's something very resistant to erosion, so that's another clue. It's some kind of strongly cemented rock or a lava that's hard to erode compared to the sediment in front of it.
Okay, thanks a lot.
All right, thank you, Dave. And we're going to go now to CBS News and Bill Harwood. Hi, Bill.
Hey, thank you very much. Two quick ones for Jim. Can you refresh my memory on the long axis of the red ellipse, how long that is, either in miles or kilometers? In other words, I'm trying to know how far away the entry point is from the current position. And second question, related, realizing you're going to stop as required to do science along the way, can you give me a ballpark idea of how long you would expect to need to get to the entry point? Maybe, bound that somehow for me. Thanks.
Just as a general idea, the ellipse is about 8 kilometers long. The actual path we take, as you can expect, if we go from place to place, is going to be longer than that. As a general idea, we know we're going to start in a few weeks. I would have to say it's very difficult to say exactly how long it's going to take. If you drove full tilt, it's going to be significantly shorter than if you actually, fulfilled the engineering and science requests on stopping locations, as you can expect. I would hazard a guess that somewhere between 10 months, a year might be something like a fast pace. If there's really scientifically interesting things that we find, we'll stay until we've completed.
Okay. We're going to go to our next question now, which is Jonathan Amos from the BBC. Hi, Jonathan.
Hi, Jane. Thanks very much for doing this. I don't know if you guys can be any more clear about the time of when you'll sort of pick up and leave Sheepbed to begin this drive out of Yellowknife Bay, and then also what is it that defines the entry point to Mount Sharp? I mean, I assume it's that great big black sand dune that skirts the edge. But I mean, what is that just not evident at the entry?
I think there's two things. One is that's a place where the rover can get past the dunes to Mount Sharp, and also, we've spent a lot of time, the rover engineers, looking at the 3D terrain and where the rover can actually drive, where it's not too steep. And they found good routes in that area for getting up across the layers that are of interest to us.
And then a time for picking up from Yellowknife and starting the climb back out?
Well, within a few weeks.
Okay.
All right. Next we go to Alan Boyle of NBC News.
Hi. Maybe this is for Joy, but just wanted to ask about the Mars rat, because that created such a splash. Anything that you want to say about characterizing those particular types of rocks, and are you seeing more of that type of structure? I imagine there will be lots of anomalous things that pop up as you look at layered rock and the sorts of things that you're seeing at Shaler.
So in all honesty, I think that the scientists that get so much more engrossed in the interesting textures and trying to figure out how the rocks formed, that we're amused when people point out that the shape happens to look like something else, but we don't spend a lot of time thinking about why that is. But it's clearly, it results from, you know, a lot of things like wind erosion and mechanical abrasion and breakdown chemical weathering of the rocks as to why they get these weird shapes. It's kind of fun in a way, too, in that it will attract a lot of the public to look at the images and learn a little bit about Mars by pulling them in this way.
Okay, we're gonna go now to Irene Klotz from Reuters. Hi.
Hi, Jane. Thank you. I have two questions, one for Jim and one for Joy. For Jim, could you just tell us where the rover is now? I think you had mentioned, or maybe it was Joe who said the commands to, I think it was you, to move the rover were sent up Monday, so it's Wednesday now, and just was wondering where it is. And then for Joy, when conjunction started, there was still some sample from the John Klein rock that was to be processed, and I think the idea was to see if you could get a higher concentration of organics. I understand the second drill sampling is still still going on, but could you give us any other information about what you've learned about the materials from the John Klein sample? Thanks.
Well, the SAM and ChemIn teams are working on those two data sets. Everything they've done on John Klein and then the Cumberland sample. But they're not ready. They're not ready to report on that. And they're still working on those results. But what they did try to do, as Joe mentioned, was to get a feel for the variability of the mineralogy and chemistry by drilling into a spot nearby that looked a little bit different, that had the concretions in it, and just to try to get a feel for the range of variability within that sheepbed rock unit.
Thanks. And the rover's current location?
Right now we're in the middle of the traverse from Cumberland over to Shaler. The total distance of that is going to be, 30, 40 meters, something like that. We're probably somewhere, we are in the middle of that, maybe 3 or 4 meters along that way. The bulk of the driving is going to come up in the next day or so.
Thank you.
Okay, thanks. And we're going to go now to AmericanSpace.com and Jason Rinn. You there, Jason?
Yes, I'm here. Listen, I have a quick question. I was wondering if there are certain things that people are, that the scientists on the scene are seeing that are guiding where they're directing curiosity. I heard earlier that they basically, as they see science, that they think they want to check out or things they want to look at, they'll spend a little bit longer at the scene. And given that Curiosity's primary mission, I believe, is to search out for microbial life, I was wondering if there's anything in particular along those lines that scientists have seen that are kind of guiding where they're directing Curiosity to go.
Well, I guess as we've described, we have these three things that we want to finish up, and you can see the traverse with Dan is to check the hydrogen or bound water variation between these two units that we're at now. Going back and following up at Shaler and Point Lake. Now from here to Mount Sharp, we're using the orbiters to help guide us where we want to go. And the primary goal is going to be to characterize the different rock types that we encounter along the way, to study contacts between the different rock units, and look at lateral changes within units. So just like a geologist that's on a field trip, you'll probably notice that we're going to tend to stop at outcrops where there's large exposures of rock